models which provide generative capabilities which are trained on massive data of text, images, audio, video, structured data which are in tables and files in typical enterprises, and also any of that structured data like news media and the social media and so on. So these deeply trained models are not only good at recognizing patterns, but also can generate or synthesize new outputs based on what they are trained on. So this leads to the capability to compose answers or come up with answers, create summaries, generate new images, audios, and videos. So while the deep learning transformer models, which have been in the industry for last 5 years or more, had shown similar capabilities earlier, it reached a threshold when they are trained on practically all available pieces of information that led to humongous models with hundreds of billions of parameters. We'll not get into the technical details here. The learning from unlabeled data, that is one of the capability, because earlier you need to really label the data, which is what is current, what is not, what's categorized, different things. That's what we call a labeling of the data. That was one of the major hindrances in training the AI models. By automatically labeling by itself, it's self-learning, which is one of the dream of AI researchers, that did the trick of this massive training. So in this session, of course, our objective is not to explain or discuss how they work, but what are the impacts of these emerging powerful AI models. So again, one more sentence. There are some set of capabilities. The fonts are a little smaller here. Apologize for that. The picture on the left bottom is an award-winning painting created by Midjourney, a generative AI program. And then we also heard news about GPT-4 passed the American Uniform Bar Examination in the 90th percentile. Another report says that foundation models perform better than many medical graduates in the med school exams. Some of the leading tech companies have demonstrated how bug-free, well-annotated code that can be generated using generative AI models. These are definitely very, very impressive. And some say the dream comes true for the AI world. At the same time, it is important to note that most generative AI applications are simply composing from what it has seen and what it is trained on. So the behavior of creating something apparently new or answering questions sometimes are good enough to be valuable to solve the problem, but may not be necessarily a sign of real intelligence or understanding of the fundamental principles of the domain. And that's kind of lead to all other concerns, right? We'll talk about that. The fact that these systems are unable to explain, and most often they are not based on domain principles, is very alarming. A good auto mechanic, to say an analogy, a good auto mechanic can repair an engine or even build one without knowing anything about thermodynamics or combustion or principles of gear mechanisms and so on. Right? So that's the kind of terrain we are moving to. So foundation models are not different. It can definitely do an amazing job in solving some of the seemingly cognitive functions. Moreover, it's a great start and bootstrap to build domain-specific applications with relatively limited data sets. So while the performance is too impressive, with signs of having, it shows the signs of having no foundations in codes. That is basically what I mean by foundations is the understanding of the basics of science or the rules and the principles of the domain. That leads to a lot of concerns of excessive usage of this technology. These concerns emanate from the unleashed power to do many things which educated professionals are doing currently, and also concerned from the fact that those tasks are done as a black box. So let's look at each one of these areas of concern.